Now in this presentation, I'll show you what kind of thermodynamic database we have in the FactSage, especially for the steelmaking applications. So this actually slide actually have the couple of the content, and first I'll show you briefly what's the history of the thermodynamic database development, and then I'll show you steelmaking chemistry and the available database for each actually the pages, and show you some of the important phase diagram which is related to the steelmaking process. And then I'll briefly show you about the modified quasi-chemical model which we are using for the slag and the molten steel. And then lastly, I'll show you the viscosity model in the FactSage, and then how we actually doing viscosity calculation compared to the slag structure. So from now on, let me show you the brief history of the FactSage database. So PACT software was developed from 1976 by the CRCT group in Montreal, and, and it was continued its history until 2001. And in 2001, this PACT software and then ChemSage from the, the package which was developed by the GTT technology in Germany merged together, and it became FactSage. So until 1998, we have only one database, which is called the PACT database. And then from 99 to 2003, we changed the name of the PACT database into the PACT 5.3 database with the window version of the FactSage. And between 2000 and 2004, we had a very large industrial project to develop the thermodynamic database for the FactSage. And so after that, we start to dissociate our PACT 5.3 database into the different database, which is specialized for the various applications. So at the time, we start to make FT Oxide, which is mainly containing Oxide database, and FT miscellaneous, FT whole, which whole Herald process, and FT salt, which is the molten salt or solid salt database, and FT Helgerson database. And Helgerson database is for the aqueous solution or corrosion application. And also at the same time, we developed many alloy database for the phase diagram calculation and phase transformation calculation for the alloys. So including the FS steel database for the steel calculation, FS light database for the light alloy such as the aluminum and the magnesium alloys, and FS copper database which for the copper alloys. And then also we include SGT database as one of the database we provide in the FactSage. And from 2004 to 2010, we have several mini consortium actually was developed within the FactSage group. And one of them is Aluminum Consortium, which is sponsored by the three major aluminum company in the world. And then we have the Glass Consortium, sponsored also by the major glass making company. And then light alloy database was further developed with GM, General Motors in Canada. And also, especially for the steelmaking, from 2009 to until now, we have the consortium of the all steelmaking company. And this actually the steelmaking company, this consortium database is named as CON1, CON2, and now it's CON3 database is available for the consortium members of these consortium members in steelmaking. Now let me show you the important thermodynamic database for the steelmaking application. So in the typical steelmaking calculation, we are using this kind of database here. The very first one is PACT PS database, and PACT PS database is the pure stoichiometric compound. So it doesn't have the solution database. However, it containing a lot of the metallic oxide and also gas data. And especially in terms of the gas species, the PACT PS database is always necessary. So when you control the partial pressure of oxygen or nitrogen or hydrogen and etc., we have to always choose the packed PS database. And we have the FT Oxide Database, which is containing a lot of the oxide solid solution and the stoichiometric phase. And we have slag database, and also we have slag solution, we have spinel solution, monoxide solution, and all kinds of other solutions. I'll explain this one later. And then also frequently we are using FT miscellaneous, especially inside of this database we choose FELQ solution phase. And this FELQ solution database is most reliable liquid steel database for the steel making calculation, and it's especially for the low carbon steel. So when you do the slag metal calculation, and in the metal is low carbon steel, this FELQ from the FT miscellaneous database is very accurate. And then also we have the so-called FS steel database, and this was originally developed for the phase diagram calculation and phase transformation calculation for the steel or steel alloys. And however, the liquid data, liquid phase in FS steel database is also very good for the slag liquid steel calculation. So especially when you go to the high alloy steel, this steel database is necessary to calculate the steel making calculation. And now I'll show you the detail about the FT Oxide database. As I mentioned, FT Oxide containing fully consistent oxide solution database and the compound database. And especially for the steel making condition, which is above the 1550 degrees Celsius, this kind of the solution is frequently used in the thermodynamic calculation. So we have the slag solution, which contains CaO, MgO, EL2O3, SiO2, and etc. And also this slag containing sodium, potassium, lithium, barium, and etc., which is important for the mold flux application or special flux application. So any kind of oxide, oxyfluoride, oxysulfide is covered by this slag database. And next, the most important probably page in the oxide database is spinel solution page. And spinel is actually having many different kinds of the spinel is known as many different kinds of compound in the steelmaking industry. So for example, MgAl2O4 is the one of the spinel phase. MgCl2O4, the refractory material, is also spinel phase. And then FeAl2O4 and Cr3O4, etc. And also MnAl2O4, typically known as inclusion. This is also part of the spinel solution. So if you want to if you want to do the calculation related to the refractory or inclusion, which containing these kinds of species, we have to use spinel database. And then we have the dicalcium silicate, alpha C2S and the beta C2S phase. And in many actual steelmaking conditions, as you know, we want to saturate the slag with a C2S. And so this is the C2S phase. So we have to select this kind of phase. And there's another important actually solid solution, which is called olivine solid solution. As you know, Mg2SiO4 olivine is, or postrite, is typically used as a refractory material in the tundish. And so this kind of the, in order to actually understand those kinds of in order to understand the chemical reaction of those refractory material with slag, we have to include olivine phase. And also in many actually the inclusion actual calculation with in inclusion calculation, we sometimes see the Mn2SiO4, which is product of the Mn and Si deoxidation. Then we also have to include this one. We have to, in order to actually activate this kind of the phase, we also have to use the olivine phase. And corundum phase is the typically known as Al2O3 solid solution. But however, the Al2O3, chromium oxide, Mn2O3, Fe2O3, all this one make a kind of solid solution, and this is so-called corundum solid solution phase. And we have as a refractory, we are typically using MgO, mag carbon refractory, and also we have a lot, in many cases we have CaO saturation. And all those kinds of MgO, CaO, FeO, MnO, NiO, and etc., which make so-called monoxide phase or halide phase. So we have to use this kind of phase in the thermodynamic calculation as well. And then when you add manganese and titanium together, so for example, if you are steel containing both manganese and the titanium as alloying element, we see a lot of the inclusion phase which containing titanium oxide. And so we have ilmenite phase, pseudobrookite phase, titanium spinel phase, and rutile phase. And all this actually the chemistry is covered by this kind of solid solution. And we have Al2O3 SiO2, 3Al2O3 2SiO2 phase. We call it typically mullite. And this is the actually not stoichiometric phase. This is non-stoichiometric solid solution phase. And so in order to do the more proper calculation, accurate calculation, we have to use the mullite solution as well. And when you typically do the solidification of the slag, many the blast furnace slag ended up as a malleolite mineral phase during the solidification. So malleolite is typically in steel making. Malleolite is typically combination of the alkamonite, Ca2MgSi2O7, and the galenite, Ca2Al2Si O7 solid solution. And this solid solution also containing certain amount of iron, and also this can expand it to the sodium oxide containing system as well. And those are the most important solid solution and the slag phase above than 1550 degrees Celsius process. And now when you do the casting, especially for the casting for with the mold flux, and also when you consider the inclusion during the solidification, we have to consider the following phase as well. So we have the so-called ulastonite phase, which is the CaSiO3 rich phase, which containing certain amount of magnesium oxide and the manganese oxide. And the melting temperature of this one is just below the 1550 degrees Celsius. And we also have the pyroxene phase, and pyroxene have the many different kinds of pyroxene, the form, protopyroxene, osopyroxene, and clinopyroxene, and etc. And this is mainly MgSiO3 rich phase and also diopside phase, CaMgSi2O6 phase. And we have so-called rhodonite phase, which is the MnSiO3 rich phase, and this is also sometimes formed as inclusion in the steelmaking process. And when you actually make a slag in the oxidizing condition with iron oxide, then we have the Fe3O4 can be formed in the as a solid solution. Also, when you're actually doing the sintering process, iron ore sintering process, iron ore is typically stay as iron 3+. So in that case, we have a lot of the solid solution between iron 3+ and aluminum 3+. And all this kind of solid solution is basically Ca, alumina, and the Fe2O3 solid solution, which is important for the oxidizing condition, typically in air or in the iron ore sintering condition, not very reducing condition, but more oxidizing condition. And this kind of phase is typically formed with the addition of the sodium oxide. And so this is important for the mold flux. So we have so-called nepheline solid solution, NaAlSiO4 solid solution, and then the NaAlSiO4 actually have the two kinds of phase. One is nepheline, the other is carnesiite, and so both of this one is important. And we have also NaAlO2 phase, and we have so-called combiite phase, which is also frequently seen in the mold flux application. And we have, of course, feldspar, which is very large solid solution between anosite and then albite. And then we have the couple of the other solid solution phase. It's also forming in some mold flux application. In terms of the liquid steel, as I mentioned, we have the two kinds of liquid steel available for the steel making calculation. One of them is FeLQ database in the FT miscellaneous solid solution. And this database covering wide range of the elements, as you can see here. And this actually database is based on the so-called Wagner interaction parameter formalism or unified interaction parameter formalism. And most of this interaction parameter was re-evaluated and also taken from the JSPS, Japanese kind of the compilation book for the interaction parameter. And so this kind of database is very good for the steel making application, especially for low carbon steel. And in the FS steel database, we also have liquid phase. And when you actually select FS steel database, this FS steel liquid database is developed by using the modified quasi-chemical model, and which actually considering the more ordering considering the ordering structure of the species in the liquid state, and especially oxygen, sulfur, nitrogen, phosphorus are well actually described inside of this kind of the solution phase. So when you go to the high alloy steel, so for example, high manganese steel and high aluminum steel, high silicon steel, and etc., you had better use this liquid database for the thermodynamic calculation. And also, if you want to do the special alloys, and also if you want to do the stainless steel calculation, this FS steel liquid database is better than the FELQ database. So, and sometimes it's very confusing whether we have to use the FELQ database or liquid database from FS steel to describe the liquid steel in thermodynamic calculation. If you're actually not sure about which database you have to use, you can contact me, then I can give you the best recommendation. And also inside of steel database, we have all kinds of solid phase and FCC, BCC, and all kinds of carbide, nitride, and etc. So we can actually do a lot of the solid state phase diagram calculation or phase transformation calculation as well. And especially in this day, we know that there was some new alloy is developed with a high aluminum containing steel and also containing order disorder transition, actually the combination. And all this one is actually well described inside of the FS steel database. So in terms of the steel making chemistry point of view, this is actually the chemistry which we can cover from the FACSAGE database. So as you can see here, blue showing that this was available only at the 6.4 database, and green was covered after 7.0 database, and then red is covered by the new database, FACSAGE 8.0. So when you're actually doing when you're actually considering the slag in the refining process in steel making or non-ferrous metallurgy, we have CaO, MgO, FeO, SiO2, and CaO, FeO, Fe2O3, SiO2, MgO, MnO, P2O5 system, which is important for the BOF. And the full range of this database, full range of this system is covered in our FACSAGE database. And then also this kind of the typical ladle refining process slag is very well covered by the our database. And also this kind of stainless steel refining, AOD, VOD process, and also high manganese steel application. And all of this kind of slag system is very well covered in our database. And also in the last couple of years, we have developed, and we have opened our database, especially for the mold plug in the casting process. So here we have now mold plugs with a typical slag composition with the sodium oxide, potassium oxide, lithium, and the fluorine combination is now available in the FACSAGE database. And also barium oxide or strontium oxide containing database with the boron oxide is also available in the FACSAGE 8.0 database. And in terms of the non-metallic inclusion, this is typical inclusion we can see in the different kinds of the steel, and all of this actual chemistry is well covered in our database. And also in terms of refractory, this is typical refractory material we are using in the different process, and all of them is very well covered. So in general, I would say the current FACSAGE 8.0 database can cover the most of the steel making the chemistry. So you can have the slag, refractory, inclusion, liquid steel, and the gas equilibration calculation very accurately with the current FactSage database. And after this actual slide, you can see a lot of the phase diagram, which is important for the steelmaking application. So I recommend you to read all these kinds of phase diagram. And then also, if you are interested about the modified chemical model, which considering the short range ordering or slag structure, then you can actually look at the related slide later. And also, if you are interested about the FactSage viscosity model, which is so-called the structural viscosity model, considering the structure of the silicate in the slag, then you can look at the actual related slide at the end of this presentation. Okay, with that, thanks for your attention. Thank you very much.